The aim of this experiment is to determine the speed of a pulse propagated through a stretched string or a slinky, which is also considered as a helical spring. The material required is a slinky and a stopwatch. So we will first measure the length of the slinky, and then, as we know that there are two types of waves, transverse waves and longitudinal waves, we will create a transverse wave and note down the time taken to for one complete wave to travel through the slinky. And we already have measured the length of the slinky, using which we will find the speed of the pulse. And similarly, we'll do the same experiment using a longitudinal wave, when we will compress the slinky and then we will see how the speed of the pulse varies. So we'll be fixing the slinky to a rigid support and we will note down the length, and then we will give it a sideways jerk. So the wave will travel like this. So this is a transverse wave, and we will note down the time taken for one complete wave to travel through the slinky and make our calculations. Let us see how this works. The apparatus for this experiment is a slinky, a stopwatch and a scale. We have now hung this slinky on a rigid support, and using the scale we will measure the length. So you can see that the length is around 44 centimeters, 43 centimeters to be precise. So this is the length of the slinky when freely hung on a rigid support, that's 43 centimeters. We have now arranged the slinky like this, and we'll give it a horizontal jerk to create a transverse wave. Let us see how much time it takes to complete one wave. In the second case, we have again fixed the slinky to a rigid support, and this time we will give it a compression, creating a longitudinal wave that comprises of compressions and rarefactions, and then we will again note the time taken by the disturbance to travel through the slinky, and then we'll make our calculations to find out the speed of the pulse when it travels in the form of a longitudinal wave. Let us see how this is performed. Give a slight push to the slinky to create a longitudinal wave and note down the time taken by the wave to travel to and fro. You can take multiple readings and later calculate the mean time taken. Let us now perform the calculations. So we found that the length of the slinky that we used for the experiment was 43 centimeters when it was freely suspended from a support, and if we convert 43 centimeters to meters, we get 43 upon 100 meters. And the mean time taken for the pulse to move, we repeated the experiment 3 to 4 times and we noted down the time taken in every case, and then we calculated the mean. The mean that was calculated was 33.5 milliseconds for one-way movement. So if we convert this to seconds, it becomes 33.5 divided by 1000 seconds. So for calculating the velocity, it's the distance traveled upon time. So using the calculations, using the numbers given here, you will find that the average speed would be somewhere around like 43 upon 100, that is the length, divided by 33.5 upon 1000. So you can just check with your calculations and give the final answer. So I hope all of you have completed your calculations, and the final answer that you would get for this is 1.28 meters per second. So the speed of the pulse propagated through the stretched slinky that we used was 1.28 meters per second.